Hey, welcome back for another video. In this video, we're going to start talking about and going through some of the Windows API. Windows API is one of the core fundamental requirements for malware development in a Windows environment. The Windows API is an interface designed by Microsoft that allows programmers to interact with the operating system in various different ways. They make it very easy to do things like creating files, manipulating memory, manipulating the system as a whole, and it's very well documented. Right here on the left of the screen, hopefully this layout works for this video. I'm going to try to keep it like this. That way, instead of flipping back and forth between windows, we have everything in this one window. So this is the Windows API index, and this is under the Microsoft documentation. In the Windows API, there are like thousands of APIs, thousands of pages of documentation. Everything is very well documented, and it can be a little bit cumbersome and overwhelming to try to understand. So that's why I wanted to make this video. When you're learning or working with Windows API, Google is going to definitely be your friend, as well as existing ideas or existing programs out there. Say, for example, if you wanted to create a file, you can jump into the Windows API and do your searching there, or you could jump to Google and see what existing solutions are done. Looking at existing solutions is going to be the best way to build comfort in the Windows API and how other people use it. Over time, you'll learn and better understand how to digest the information provided in the documentation. But once you do understand it, this documentation is fantastic and will help you on your way of creating whatever you want while interacting with the API. So to start off, I just want to go over some common data types that you'll encounter when you're working with the Windows API. So I'm just going to paste some things over here and just give a quick rundown of what each thing is. So to start with, the first type is handle, and you'll see if I type handle here, I'm going to have an error, and that's because the type handle is unknown. And that's because we haven't actually imported the Windows API. To import and utilize Windows API, you need to include that header. And to do that, you do include windows.h. This includes all of the core Windows API headers and anything required for the base Windows API. So your types such as handle and things like that will all be included in that. So this first type, handle, this is a handle to an object. It's an opaque value that's used to represent various types of objects in Windows, such as files, windows, or devices. And an example handle would be, should have formatted this a little better, but so here we are running create file. Create file is an API in Windows API. All of this is documented, and we'll look at this in more detail later. But the result of create file returns a handle. This handle is, as we said, it's a reference value to files or windows or whatever else. So it's creating a reference to our file that we're creating named example.txt. Next on the list is the handle to a window, and this is written like this: handle to a window. And handle to a window is the same as a handle, but it is to a window. So a window would be like, for example, this Visual Studio window is a window. This browser window here is considered a window. The overlay for my OBS recording, for me recording this this video, is a transparent window that you cannot see. So we could, in theory, get a handle to this transparent window or any of the other windows. We can also create a new window, and running create window ex returns a handle to a window. Okay, and moving on, we have a handle to an instance. That looks like this. So a handle to an instance is another reference as a handle to a module, or a module handle. This is just used to identify the instance of an application or DLL. So when you run get module handle returns a module handle, and this is of type H instance. Next up, we have void. So void looks like this. Void, in this case, or in the context of functions, or this specific function, it means that the function, my function, is returning nothing. So void is empty or nothing. Next up, we have HModule, and HModule looks like this. So when we run load library, it returns a HModule, and this is the handle to a module, similar to the H instance. This module could be like an executable or a DLL, and it's used in functions that load, manipulate, or retrieve information about modules. For example, get module handle, like we looked at earlier, and load library are two functions that return an HModule. Can be kind of confusing, but it is essentially the same thing as H instance. But HModule is used specifically for modules. The next thing on the list, we have size t. This is an unsigned integer that's the result of the size of operator, and it's used to represent the size of an object. It's used extensively, like you're going to see size t used all throughout Windows API for memory allocation and things like that. So it is very important to understand this data type. Next up, we have ulong pointer. This is an unsigned long type that is used for precise pointers. It's defined as an unsigned integer that's large enough to store the full width of a pointer. This makes it suitable for storing pointers as integer values, especially for casting pointers to integers and vice versa. Next up, we have pvoid. So this is a pointer to void. It's used in situations where you want to write generic functions or APIs that can accept pointers to any kind of data. So in this example, we're allocating some memory space and just creating and then it's returning a pointer, or a void pointer to that memory address. Next up, we have dword. Dwords are 32-bit unsigned integers. They are used a lot in Windows API for flags, bit fields, and other values. And then we have words. Words are 16 4-bit unsigned integers. They're used for smaller numerical values. Less common, I would say, in Windows API, but still used. Then we have a byte type, which is an 8-bit unsigned integer. It's used for binary values or binary data and booleans and things like that. You will see byte used a lot, especially if you're manipulating and moving shellcode around and stuff like that. So I would familiarize yourself with byte values. Following that, we have an LP string, which is a pointer to a null terminated string of 8-bit Windows ANSI characters. That can be kind of confusing, but ANSI characters, they're essentially the characters that you're used to seeing, but they're the 8-bit values. And you'll see in a minute the kind of the difference of the two, at least from like a programming perspective. Next up, we have the LPC string, and I'm going to put this one just below. So the LPC string is it is an LP string, but it's a constant value. So, and then next up, we have LPCW string. The difference between a LPW string and LP string is this character here. This is how you differentiate the two, in my opinion anyways. There may be a better way, but a W string is a pointer to a null terminated string of 16-bit Unicode characters. So the difference here is that these are Unicode, they're 16-bit, these are ANSI, and they are 8-bit. And a side note to that is the ANSI is generally converted to Unicode eventually. So where you can use Unicode, which is W, it's better to use it just from an efficiency perspective. And then next up we have LPCW string, which is still a W string, but it is a constant. And following that, we have param, which is a message parameter used in message handling functions. It is a signed value that can vary in size between 32 and 64-bit environments. And next up we have wparam. This is similar to lparam, but it's unsigned. It's still the same. It can vary in size. And after that, we've got uint, which is an unsigned integer. The size can vary, but it's used for unsigned values that aren't expected to be very large. And next we have long, which is a 32-bit signed integer that's used for a bunch of different things, like specifying coordinates and stuff like that. And the last one that we're going to look at is the LPC void, and this is similar to the LP void that we were looking at earlier, that points to it points to a void location in memory, but in this case it's a constant, meaning that we won't make changes or be expected to make changes through this LPC void pointer to that memory location. It would, in this case, be considered read-only. Okay, so that's it for the types. There are a lot more types, but these are some of the most common types that you're gonna see, at least when you're getting started. And maybe that'll help you like slowly digest and create like a starting point. The next thing that I want to look at is I want to look at just an example of write process memory. I'm going to paste some of the code here, and this is, and right here we have the Windows API page for it. So this is the function write process memory in Windows API. You will use this if you're doing malware development. It's inevitable. So let's just look through the Windows API documentation really quick and try to digest what this function does, how the parameters are given and decided, and just kind of go from there. So first up, we have a description. Writes data to an area of memory specified in a process. The entire area to be written must be accessible or the operation fails. Okay, so we know this writes memory to a specified process. All right, and then we can see here we have these parameters. Looks like we have 4 parameters that are in and 1 parameter that is out. It's common to see in and out parameters. There's also optional. You'll see optional fairly often. Optional doesn't always mean optional. Sometimes it means optional based on certain cases. But for in and out is always, you can think of in as a parameter that you will be providing into the function. Out is a parameter that you will provide and the function will give something back or return something from the function. So looking at the parameters, our first parameter in is HProcess. What is HProcess? It is a handle to the process memory to be modified. This handle must have process VM write and process VM operation access to the process. Okay, this is good information. So that would mean that we need to get a handle to some process, and then when we get that handle, we need to apply these permissions on that handle, and then we just provide the returned handle here in this field. Next up, we have LP base address. This is a pointer to the base address in the specified process where the data is written. So we have our handle to our process. Now we want to know where in our process we're going to write this data, whatever we're writing, into memory. Okay, that makes sense. Next up, LP buffer. This is this LPC void. It is also an in parameter. This one is a pointer to a buffer that contains data to be written to the space of the address. Okay, so now we know we have our process. Then we have the address that we want to write to in our process. Next, we have the data that we want to write into that address. So what's next? Next, we have size. This is the number of bytes to be written. So this is how we know how much data we're going to be writing into the process. This is just part of memory management here. And finally, we have out, which is the number of bytes written. This is a pointer to a variable that receives the number of bytes that were transferred into the specified process. This parameter is optional. If the value is set to null, this parameter is set to null, then the parameter is just ignored. Okay, so even though here and here, it doesn't say that it's optional, it is still considered optional. You can just provide a null here, and the parameter will be ignored. Awesome. Or you can provide a parameter so that you can track the number of bytes that were written in this function call. Okay, so next up we have our return value, and we can see if the function succeeds, the return value is not 0. If the function fails, the return value is 0. Okay, so these are this is essentially a boolean, right? So you have your bool here. So you'll get a 0 or not 0, which is most likely going to be a 1. And to get extended error information, you can call get last error. So if we take a look at get last error, this returns the thread's last error code. And so if we wanted to pull up error codes and take it even further, here we have all of these error codes, 15,000 error codes. And if you look through them, you can see 0 correlates to error success, 1, 2, these all correlate to something. So very well documented. You can tell exactly what your error is if you get an error. All you have to do is call get last error. So what you would do here is you would check to see if the Boolean value returned from write process memory is 0. If it is not 0, or I'm sorry, if it is 0, then you just call get last error and print out that error, or do whatever you need to do to handle that error, and you can proceed from there. Finally, there are some remarks on the function. So these remarks can get very detailed. This is just additional information. If you're planning on using a function, you're not sure how it works or what, just in general, you're looking for more contextual information, remarks is a good place to look. Okay, so let's continue forward, and let's actually try to put together some code. And for this code, what we want to do is, I'm going to write some comments. We want to create a file. We'll create a text file. And then we want to write something into that file. Okay, so this is going to be a couple of different API calls, and after we run, we should get a created text file that has our expected data written into it. Okay, so to do that, first thing we want to do is make sure that we have windows.h included, and I will just create our main function here. And to create our file, first thing we want to do, if you have the Windows API open, over on the left, if it's full screened, let me just see if I can pull this over. Yeah, so you have a search over here. So you could do a search for like create file, or you could Google it, whatever works best for you. You can see here we have, I'll just click on this one. So we have two functions here. We have a create file W and a create file A. What's the difference between the two? Well, we talked about this a little bit when we were looking at the data types. We have the A, which is the ANSI characters, and the W, which is Unicode characters. Where possible, as I said before, you definitely want to use the W functions, because at the end of the day, the ANSI characters will be converted to Unicode. So it is a more efficient process to use the ANSI, or to use the Unicode functions, which are the W's, where possible. It's not always possible, but where you can, definitely do. Okay, so let's work through this function. So what I'm going to do is I'm going to copy this, and I'm just going to paste it in our code. Pull this over, and the first thing, we'll just go parameter by parameter. So first up, we have LP file name, and for that, this is the name of the file or device to be created or opened. So for this, you could do this a couple of different ways. I'm going to You can see it's an LPCW string, so it's a constant W string. So I will just create a string named file name, and I'll just call it example.text if I can type. Now you'll see that this will stay squiggled. It's an error. That's because this const char or a regular string, ANSI string, is not a W string. And to change it to a W string, just add your L here. And now you have a good LPCW string to use. So then we can put our parameter here, file name, and that's our first parameter. Awesome. So moving forward, let's look at our next parameter, which is DW desired access. So this, the requested access to a file, which can be summarized as read, write, or both, or neither, which is 0. The most commonly used values are generic read and generic write, or both. Put in like this: generic read, pipe generic write. And this is what we're going to use because we're opening our file, and we're going to use that same handle, this handle, to write to that file. So let's go ahead and put this in for the next function. I just noticed we don't actually have a file name or a handle name. So let's call this handle to file, like so. Okay. The next parameter, DW share mode. The requested sharing mode of the file or device, which can be read, write, both, delete, all, or none. We're not doing any sort of sharing in this example, so we're just going to set this value to 0. To do that, we'll just erase all of this and drop a 0 here. Move on to the next. Next is LP security attributes. So here you can see, before we move on, to find the 0 value, if the parameter is 0, here's this information, and then here you can see the values that correlate to the meaning. Okay, so moving on. Next up we have in, which is optional. LP security attributes is a pointer to a security attribute structure that contains 2 separate but related data members. Okay, here we can see in bold, null. This parameter can be null. If the parameter is null, then the handle returned cannot be inherited by any child process. Okay, we don't care about that. We're not using a child process here, so let's just set this parameter to null. Perfect. All right, moving on. Next up, we have DW create disposition. Here, an action to take on a file or device that exists or does not exist. Okay, so based on whether or not the file exists, something happens. Okay. For devices other than files, the parameter is usually open existing, but we are interacting with a file. So let's just look through what we have here. So create always creates a new file. Okay, this is an option. Create a new file only if the file does not already exist. Also an option. Open a file always. This is not an option. Or I'm sorry, this is also an option. So no matter what, whether the file exists or not, we will open the file. Next up we have open existing. Opens a file only if it exists. That's not an option because we are not expecting our file to exist. And then truncate existing. Open a file and truncate it so that the size is 0 bytes. Only if it exists. Also not relevant to what we're doing. So we have some choices between create always, create new, and open always. In this case, the best option here is open always, because it will always open the handle whether or not the file exists, which is what we want. So let's go here and we will put open always. Awesome. Okay. Now next up we have DW flags and attributes. So the file or device attributes and flags, file attribute normal being the most common default value for flags. Hint, hint. Okay, so we can scroll down here and we have all of these attributes and their associated meanings. Looking at file attribute normal, the file does not have an attribute set. This attribute is valid only if used alone. Okay, so we're going to use file attribute normal. Paste that in. Cool. And we have one last parameter to look at. That last parameter, hTemplate file, is a valid handle to a template file with generic read. We don't have a template file and we don't have a handle to a template file. This parameter can be null. So, okay. Let's set this parameter to null then. Awesome. Okay. And finally, the return value. If the function succeeds, the return value is an open handle to the specified file, device, name, pipe, or mail slot. If the function fails, the return value is invalid handle value. And to get extended error information, we can call getLastError. Okay, so let's do some error handling here. So we can do if handle to file is equal to invalid handle value, which is here, right? If the function fails, the return value is invalid handle value. So if it is invalid handle value, what do we want to do? We want to print failed to open or create file, and then we'll say error percent new line, and then getLastError. You can greatly simplify this and just print getLastError if you want, but I'm going to do it this way. And then we will return, just return 1. Okay, and need to import for printf, so, or include, I'm sorry. So include stdio, and we should be good on printf. Yep, okay. Cool, so now we have created a file, and file named example.txt. We have a handle to that file, and if we for some reason encounter an error, we can print the error information and exit the application. So the next thing we want to do is we want to write something to that file, right? So we have the created text file. Let's move this to here so it makes a little more sense. And now we want to write something. How do we do that? Well, let's pull this over. Let's just type write. Okay, so we can see write file right here. Let's click write file. And let's just take a look at write file. It writes data to a specified file or input-output IO device. Function is designed for both synchronous and asynchronous operations. Okay, so we can see here, first thing it takes is a handle to a file. Awesome, so that is something we can provide. Let's pull this over here and let's use write file. So to do that, let's do what we did last time, and let's paste in this function here, and we can just say write result. So we'll call our Boolean value write result, and then we'll call write file to write to our file that we created. Okay, so first things up, we have again the handle to our file. Our handle already exists here. It's hfile. Take hfile and paste hfile there. Perfect, that was easy. Next up, we have LP buffer. LP buffer is a pointer to the buffer containing the data to be written to the file. Okay, that does not exist yet. So let's create that. So we can do LPC void, or for example, we could do const char pointer, and we'll say we'll call it message, and we can just say welcome to Windows API. Okay, and then we can just take message and put that here. Okay, so now we have our message going in. Next up, we have a number of bytes to be written, and this is the number of bytes to be written to the file or device. So that is going to be essentially the size of message. So to do that, we can do string length on message. Perfect. Okay. Moving forward, we have an out optional, which is LP number of bytes written. This is a pointer to a variable that receives the number of bytes to be written when using synchronous hfile parameter. Okay. So this is an out parameter, and it is optional, but there are some caveats to the optional piece of this, right? Okay, so this parameter can be null, but only when LP overlapped parameter, which is the next parameter, is not null. Okay, so let's circle back on this one then, and let's see if we need LP overlapped. This is in, out, and optional. LP overlapped is a pointer to an overlap structure. Is required if the hfile parameter was opened with the file flag overlapped. Otherwise, it can be null. Well, what flag did we use? We used file attribute normal. Awesome. Okay, so that means that otherwise this parameter can be null. Okay, so let's set this value to null. And circle back now to our last parameter, which is number of bytes written. Okay, so this is a pointer to a variable that receives the number of bytes that are written. So this is the value of bytes that we are going to write into our file, essentially the size of this. So what we want to do is, this is a pointer, it's a pointer to a dword, right? So do dword size, or say bytes written, and we will put that value here. Perfect. Okay, we're not throwing any squiggles or syntax errors yet, so that's good. Okay, so moving forward, let's scroll down and let's see what our return values look like. So we can see if the function succeeds, the return value is non-zero, which is true. This is this Boolean value. If the function fails or is completing asynchronously, the return value is false. To get extended results, we need to call our getLastError function again. Okay, cool. So we essentially want to do the exact same thing that we did up at the top, but instead this time we're just doing it against the Boolean value. We're not checking for a specific error. So we can do if not, which means that it is false. If not right result, then we want to print f, and we'll do failed to write file. Error. And then we can just return 1 here. Okay, and finally, well, optionally we could also say else printf wrote to file successfully. Okay, so since we have that Boolean, we have the option to, add some additional logic. Okay, and finally what we want to do is we want to close our handle. If I can type to hfile, which is our file handle. I still cannot type. Okay, and return 0. That should end our function. Okay, so looking back at it, we have our create file. Our file name will be example.txt. We're going to write into that file, welcome to Windows API, with the write file API call. Okay, let's save this and build the solution. And then let's go check the folder and see if it runs. Okay, so here's our folder. You can see here my application is called Basics. When I double click this, ideally we get a file named example, but we'll see. We did. Okay, great. So when we open this file up, you can see welcome to Windows API. Nice. That's what we wanted to see. Okay, so that will conclude the basics of Windows API. I really hope that you enjoyed this video. I hope that you learned something. If you want to follow up to the Windows API content or more information in general, let me know. Let me know in the comments. Make sure that you like, comment, and subscribe if you like the content. It would really help me out. I appreciate it. Thank you.